Welcome, Algebra 1 students, to our SOL review video number 1. Henry Mancini's Pink Panther theme is playing in the background at the moment. One of my favorite songs, actually. I always used to watch those movies with my dad. Anyway, we're going to be going over some review. We're also going to be doing some test-taking strategies. And as it says right here on our meme for today, test-taking skills, more effective on the SOL than clicking your heels together 3 times. So there's no guessing, there's no praying, there's no magic to this. There is just test-taking skills. Let's both do problems and talk about test-taking skills here. All right, these are the questions released by the state. You will notice that there may already be an answer clicked on the screen for what we're looking at, but we're still going to go ahead and try the questions as we go through. So this one's simplifying a radical. So as it says, first of all, they tell us x and y are greater than 0. Well, that's good, because we've got variables inside the radical that have an odd exponent there on the x at least, so you can't have a negative there. So we know they're positive, and we're simplifying. The first thing I want you to remember here is that you should recognize when a radical is simplified. If you look, for example, these two have the number 20 in there. The number 20 has a perfect square factor of 4. So automatically, square root of 20 is not simplified. So apparently the correct answer is not what's selected there, so I'll just go ahead and X that out anyway. So let's go ahead and actually do the math then instead. All right, now I'm recognizing, and yes, I'm going to work backwards a little bit here, that we must be simplifying this radical in this manner. If we know 20 can't be it because there's that perfect square factor in there, we must be simplifying in this manner. Well, that means that 180 is 5 times 36. So I can write my radical as 36 times 5 for the 180. I can take x to the 9th and make it x to the 8th times x, and then I have y to the 16th. So I can now take the square root of everything that's a perfect square, and I can see what's going to be left. Now, because I'm dealing with multiple choice, I'm actually through at this point, because I know that that's a 6, that's an x to the 4th, and that's a y to the 8th, and I've got a 5 and an x left inside. So clearly my answer must be D. So when you're simplifying radicals, I want you to look for answer choices that are clearly wrong because they're not simplified all the way. And I want you to then go ahead and actually simplify the problem until you recognize which one is the correct answer. Awesome. Let's do another one. Okay, so here we have a radicals application problem. Not radicals, excuse me. Inequalities, linear inequalities. So linear inequalities application problem. And we are trying to figure out which one of these graphs matches the situation that we have here. I want you to start off by looking at the graphs. Okay, Frank's weekly earnings, that's the title for everything. On one axis, we have number of hours worked at night, and on the other axis, we have number of hours worked during the day. And then this is his weekly earnings, and I'm assuming that his earnings are because we've got inequalities that we're either looking for an at most or an at least situation. At most would be shaded down because that's the most it can be. It's that or less. At least would be shaded up. Let's read what they gave us. He earns $7.50 per hour when he works during the day. He earns $12.50 per hour when he works at night. He wants to earn at least $300 per week. So, if he's working during the day, he's making $7.50 an hour. Let's take a look at the graphs and look on the day side, which is the x-axis, $7.50 an hour. Okay, if he wants to make $7.50 an hour, he wants to earn at least $300. Well, if he worked only during the day, how many hours would he have to make work to make $300? So 300 divided by 7.5. Well, remember that you do have a calculator at your disposal when you're doing the math. So 300 divided by 7.5 gives me 40. What about 300 divided by the 12.50, which is the amount he makes during working at night, during the night? 300 divided by 12.50, 24 hours. So if our friend here, Frank, good old Frank, if Frank is working only during the day, he has to work 40 hours, and only at night he has to work 24 hours. So let's take a look here. Nighttime is your y-axis, 24 hours at night. Let's find that. Well, this one's 24 hours at night. This one's not. Okay, this one here, this one's 24, and this one is not. So at this point, we know it's not B and it's not D. All right, now I want to look at the rest of the information they gave me. He wants to earn at least $300 per week. At least, we already established, is going to be shaded upwards. C is my correct answer. Next question. All right, so this one gives me two relationships here. Or one relationship, excuse me. An experiment is conducted on a container of gas that is kept at constant temperature. When the pressure on the gas is 30 pounds per square inch, the volume is 120 cubic inches. When the pressure on the gas is 40 pounds per square inch, the volume is 90 cubic inches. Let's stop for a second and look at what happened in that relationship. The pounds per square inch, the pressure went up. The volume went down. That should automatically send up a red flag for you. Well, if one is going up and the other is going down, that's an inverse variation. That is an inverse variation. So if I recognize that, that's going to help me quite a bit. Take a look at your answer choices. A tells you that it's a direct variation, varies directly. B varies directly. I know it can't be A or B. Now I've got to figure out which one of these relationships, which one of these equations matches this situation. Now if I remember that xy equals k, or y equals k over x, which is the relationship we deal with an inverse variation, I should be able to recognize that the correct equation is the one that fits this format. Look at my two equations they have. This one and this one. This one right here matches this format. The variables being multiplied to give you a constant. And if you look, the constant, 30 times 120 is 3,600. And this one right here, 40 times 90, also 3,600. D is your correct answer. Next. All right, moving on to another question. This one involves Z-score. Now we have the theme song to the Hunger Games. And I'm not really sure where this came from, but I kind of like it. So we're just going to listen to it while we do this math. All right, the data set here has a mean of 37 and a standard deviation of 6.3. Let's get used to seeing those symbols so that we're comfortable with them. So maybe you go ahead and you write these two things down. Rounded to the nearest tenth, that's your standard deviation. So there's your data set right there. How many of these points have a z-score greater than negative 0.6? Okay, greater than negative 0.6. So let's think about what z-score is. Okay, z-score, x minus mu over sigma. So it's the difference between the value and the mean, and that difference divided by the standard deviation. So remember that a positive z-score is a number that's above the mean is going to have a positive z-score. So I definitely know that all of these numbers have a z-score that's got to be greater than negative 0.6. The z-score for the number 37 would be 0. Look, 37 minus the mean of 37. Doesn't matter what's in the denominator because that's 0 divided by 6.3. That's 0. So you do not have to check a lot of numbers here. We know that the answer can't be 3 or 5 because it's got to be more than this 6 that's already listed. You can go ahead and only check these 3. The other thing you could do, guys, is you could work your way from the bottom up, checking every one until you get to one that's clearly greater than negative 0, until you get to the one that's greater than negative 0.6 and figure it out that way. Let's do this way. So we have 33 minus the mean over 6.3. We have 35 minus the mean over 6.3. And finally, we have 36 minus 37, the mean, over 6.3. And those are the 3 we have to check to figure out our answer. Okay, so this one, negative 0.63. Okay, so that is not greater than negative 0.6. Negative 0.6 is a larger number than negative 0.63, so 33, nope. All right, which means our answer has to be 8. So let's do them with the 35 minus 37, divide by the standard deviation. We get negative 0.3, negative 0.317, etc., which is clearly greater than negative 0.6, so our answer is 8. Okay, good question because it really challenges whether or not you know something about standard deviation. You just got to stick it out and write it out. Next one. All right, box and whisker plots. Let's take a look. Number of points two basketball teams scored is summarized in these box and whisker plots. Oh, we know this one. We've done this one before. Team A scored a different number of points in each of 14 games. So this one is 14 games. And Team B was 13 games. What's the total number of games that Team A and B scored 55 points or more? So here's 55 and above. So we've got to figure out how to lay that out. Now for the 13 game one, recall that you'll have a median, which is one of the numbers, and then 6 values above and 6 values below. And I know that because it's an odd number, which makes the median one of the numbers, and because 13, when you cut it in half, you get 13.5, so there's 6 above and 6 below. Now this is asking about 55 or more, so that's going to be this many values. The median is 1 plus 6, so 7 values from that second team. What about of the 14? How does that work? Well, we want from the lower quartile up. And I don't want you to do anything like dividing by 4, because you have to remember that sometimes the quartile is one of the numbers and sometimes it's not. So if I have 14 values, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, the middle is not one of my values because it is even. But if I now go back and I look at the quartiles, they are numbers in my data set. They are numbers in my data set because I've got a situation where you have an odd number above and below. So I want from here upwards. So that is 1, let's count them with the pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, that's 11. 11 and 7 makes 18. 18 was the correct answer. Next question. All right, identify each function that has exactly 1 0. All right, remember a 0 is where y equals 0, or in this case, where f of, g of, h of, j of, k of, any of them, x equals 0. So what we're doing is we're trying to find each one that has exactly 1 0. Now this is a good question for graphing on your calculator, but you can also solve it. So if I go ahead and I solve each of these equations with 0 on one side, this one right here is going to come out to 9x squared equals 4. We're going to divide both sides by 9 and have x squared equals 4/9. We're going to square root both sides and have plus or minus 2/3. Plus or minus, that's 2 zeros. Nope. All right, this next one is linear. 0 equals 9 times the quantity x minus 8. That is definitely going to have 1 0. It's going to have a 0 of 8, I believe. If I divide both sides by 9, I have x minus 8 equals 0, so x must equal 8. So that has 1 0. If you continue on, this one right here has no zeros. None at all. Because it's not factorable. And if you go ahead and you try and graph it, you'll see that it won't cross the x-axis. This one has 2 zeros. So I know that can't be it. This one is a perfect square. So there are a lot of patterns here that if I recognize those patterns, I can use them and save myself some time. Excuse me. So x would equal 4, and that's your 1 0. So this problem has 2 correct answers. Awesome. Next question. This one's super fast and easy. So on this question, you'd be plotting your answers, and you must plot all solutions. So it says that it wants us to identify each solution of f of x equals 0. Well, if f of x equals 0, that's y equaling 0, and that's on the x-axis. So the solutions, remember, are the roots, the zeros, the x-intercepts. So on a question, I can't apparently spell intercepts. On a question like this, your goal is to plot or click on the zeros, and it'll give you a little cursor, and you actually just click on them, little red dots like that, and that would be your answer for this question. That's it. That's all you have to do is recognize that. Excuse me. Excuse me. All right, I think we only have 2 more, which is good because this is getting lengthy. Oh, a good old inequality. Now, one of the things that I want you to recognize about the inequalities they give you is that sometimes they're going to be super easy and sometimes they're going to be a little more challenging. This is not super challenging. However, you do have to recognize that you've got to combine your like terms. Once you do that, you're going to have negative 7x minus 11 is less than 7 minus 5x. You're then going to go through and solve, and it's important that you try to remember that you're either going to have to get rid of your negative variable like I just did by adding the smaller value, or you're going to have to remember to flip a symbol if you divide by a negative. So I'm just going through the steps of solving this the way that we learned, and I completely ran out of space. And I get this, divide by 2, negative 9 is less than x. Now I have recognized at this point that it is actually acceptable to type it this way. Negative 9 is less than x, or x is greater than negative 9. I would avoid putting spaces in between anything, although I don't think that'll have too big an impact on how you're scored. Okay, so that's it, guys. That's all you have to do for that. So you would type this in, one of these two answers. I think there are even more acceptable answers, and we will talk about that with the Practice SOL in class. Okay, guys, last question. And our last theme song is the Harry Potter theme song. Hedwig's theme, in fact. All right, so this one is a property question. So this is not going to take long. And then we're going to have one more slide where we're going to summarize some of our test-taking strategies that that we have gone over. You know, test-taking strategies you've been taught since, like, first grade. And yes, actually first grade. My kid is actually learning test-taking strategies already. He's got multiple choice questions to answer, and they're already teaching him how to cross off the wrong ones. So I'm not sure how they're going to approach it when they do stuff like this, but, you know, we'll have to see. All right, so this question... Choose the, click on a box to choose the property you want to select. Keep in mind that every step that they show you in solving an equation, or in this case an inequality, is done with one property in mind. So there can't be more than one correct answer on this. A question like this, I think, would actually prevent you from clicking on more than one correct answer, so that's positive. Okay, so let's take a look at what was done in this equation. They want us to identify the property that justifies steps 4 to 5, but guys, don't just go straight to there. You've got to start from the beginning and look at what they did. What did they do from step 1 to step 2? They added a -3 to both sides to get rid of that +3. And there you have it. They went ahead and actually did the plus -3. Now you have +0 and you have -2x. Now that is your identity property, showing you that adding 0 doesn't change anything, so you can take off the +0. Now we're at the point where we need to be paying close attention. So this is the step. What did they do from 4 to 5? The work between 4 and 5. And I really like the way that that's stated, because sometimes we have trouble recognizing, well, you know, which step are they asking about? This is easy, between 4 and 5. So what's different is that they've taken both sides and multiplied by -1/2. And in that process, I want you to look at that symbol. Oh, they flipped it around. So which of these properties listed has something to do with multiplying both sides by the same number? Distributive property. Clearly not. That would be if I was multiplying something like this. Inverse property of multiplication. Now, I can see how you might choose this one, but I want you to remember that that's not what's happening here, okay? Because the inverse property hasn't been used. If they had then gone through and given you that 1, now that's inverse property. And that's from step 5 to step 6. So that's not our answer either. Multiplication property of inequality, that's actually going to be your answer. We're multiplying both sides by the same number, so if that's what you came up with, good on ya. How about commutative property? Nope, that's change order. So change order. Ooh, apparently can't quite fit that there. Identity property of multiplication, that would be from 6 to 7. That's step 6 to step 7. Anything times 1 is itself, so they drop the 1. Addition property of inequality, that would be from steps 1 to 2. Not that difficult a problem after all. Let's summarize our test-taking strategies real quick and this video's over. We definitely talked about eliminating wrong answers. Now I want you to remember that eliminating wrong answers does not just mean looking and saying, oh, this answer is clearly completely out of left field. It's also, like we did on that very first question, eliminating answers that are clearly not in the right format, like not simplified completely. Okay? Read the entire question. Don't just zoom to the part you're supposed to do. That's not going to be helpful. And guys, please take your time. You cannot assume that this stuff is going to go fast and easy and simple all the way through. The point of the test is that they really want to challenge you to show what you know. Sorry about that. Okay, and we're going to leave it at that for now. We're going to have lots more test-taking strategies before the end of these videos. Thanks for sticking it out through the whole thing. I hope you enjoyed the music in the background as well. See you in class.